Hello, this is Dr. Amrudapriya, Associate Professor, Triply of Rohini College of Engineering and Technology, Palkulam. We are discussing about the transmission and distribution subject for the regulation 2021. Let us start with the grading of cables. What is grading? Grading is normally the process of achieving uniform electrostatic stress in the dielectric of cables. So what is meant by that electrostatic stress and why it is caused? Normally, cables are nothing but a core conductor which is being surrounded by insulation, and then over which we have certain layers of protection. While considering the insulation which is being rolled over the conductor, there may occur stress at the insulation level. What type of stress is going to occur? When considering the core, the surface layer which is being in contact with the insulation layer, or which is nearer to the outer surface of the conductor, it will be subjected to a greater potential stress when compared to the layer which is away from the core conductor. So normally there occurs an electrostatic stress in the insulation level, that is the dielectric of cables. In order to achieve a uniform electrostatic stress, we are applying this grading process. Why there is a need for a uniform electrostatic stress means the non-uniformity may cause breakdown of the insulation very easily. If suppose there occurs any breakdown of the insulation, automatically the conductor will be exposed to the outer surface, or it may be exposed to the ground level, and there may occur leakage of current. In order to avoid this, grading of cable is essential. What is grading? What we are going to do is we are going to have different layers of dielectrics. That may be a uniform one or non-uniform one. This is what we are going to discuss in this lecture. The first type is capacitance grading. The other one is the intersheath grading. So let us have the capacitance grading first. What we are going to do is we are going to have different layers of dielectrics, and we are going to achieve the it is a process of achieving uniformity in the dielectric stress by using layers of different dielectrics. So this is what is called capacitance grading. Here we can see that we are having three different layers, and those layers dielectrics are being represented by epsilon 1, epsilon 2, epsilon 3, etc. So all the three dielectric materials are different materials. Here, depending upon the distances, we can have the distance from the center of the core to the end of the conductor as d by 2, that is r, or radius, or we can have diameter d by 2. And next is from the core conductor till the surface of the first dielectric, it is d1 by 2. Second one is d2 by 2, and the last one is capital D by 2. So that is the total radius of the entire cable. And Gmax is the maximum electrostatic stress which may occur, and the G is being followed. We can see the graph, the pink color graph, which is being drawn with respect to the distance, the stress with respect to the distance. And next, this is the equation which we are going to, the stress is made uniform, so it is the same. Obviously we can get epsilon 1 is 1 into d is equal to epsilon 2 into d1 is equal to epsilon 3 into capital D. Now while we are considering the potential difference across the inner layer, we have to differentiate from d by 2 to d1 by 2 for the first dielectric. So substituting the value for the stress G as q by 2 pi epsilon 0 epsilon 1 into x. And here we can have dx by x as natural logarithm of x, and by integrating it we'll get this equation. Similarly for V2 and V3 we'll get a similar equation, and we are going to add all the potentials, and this will be the total potential difference. So while considering this potential difference, if the cable had a homogeneous dielectric, then for the same values of small d and capital D and Gmax, the permissible potential difference between core and earth sheath would have been this is a consolidated one if it is a homogeneous dielectric. Next is the intersheath grading. So what we are going to do in such a case is we are going to have a single material for dielectric, and between that dielectric we are going to provide lead sheet. Metallic sheets are being placed in between the insulators. Those blue color circles represents the intersheaths, metallic sheets which are being provided in between the dielectrics, but the dielectric is of same material. So we can see the diagram as it is, and next we can have G1 max, G2 max and G3 max as such. All the dielectrics are going to be same since we are going to have a homogeneous one. And finally, while you are adding the V1, V2, V3, while you are considering this, since they are like three capacitors in series, just we are going to add the potential V is equal to V1 plus V2 plus V3. Finally, this will be the equation. This is how the homogeneous dielectric case is, the maximum stress, how it is. Next, regarding the capacitance of 3-core cable, we can have this like a delta shaped one and the star shaped one. We can represent this 3-core cables conductors. I mean, it is much more different when compared to that of the it is similar to that of the overhead line cable lines. The conductor which are nearer to the each conductor and which are being earthed, this can be consolidatedly considered as star shaped one and delta shaped one. So we can see the star shape as CE, 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 and the CC, CC, CC are in delta shape. This is how we can consolidatedly find out the value for which. So the Cn value is nothing but the summation of Ce and Ce equivalent. So finally we can calculate the capacitive current to be 2 pi f V phase into Ce plus 3 Cc. Thank you.